Hi. Okay, so this will be kind of a sub lecture for CSE 101. This is not going to be a how to do PA1. This isn't going to be nearly as good as Pat explaining it, but I'll do my best to kind of explain some basic stuff, kind of like pointers, how to log into your um, timeshare. I'm gonna be doing this in Putty, in Sublime Text. I'm also gonna be using FileZilla, and then I have Git Bash. I'm not gonna explain how to do Git. I'm that's There's already a tutorial for that, and Pat linked a bunch of um, links on how to do that. Um, so for this example, um, I grabbed an old lab from um, 12B that I took over the summer a while ago. And I'm just gonna use that as an example. Um, but first of all, if you haven't already logged into your timeshare, it's really easy. If you're on a Mac, you don't need to use Putty. That's great. You can just use the standard console. If you are on Windows, you have to use Putty or any other SSH client. So it's always port 22. You can see right here it's already enabled for SSH. And the login is just your cruise ID, and then at unix.ucse.edu. And it'll open, and then it'll ask for your password. I think this is your blue password. It could be your gold, but just log in, and we're in. So we are currently in here. If you don't know Linux commands, there's only, for this class, at least for 12B, there's only 3 that I really needed to know. Um, the first one being ls. That just lists everything, all the directories. So for example, right here we have old files, CMPS 12B from when I took it, CSE 101, and some other stuff, and then a welcome. Another one you want to know is cd, which just change. It's called, I think it's change directory. So you just type cd, and then the directory you want to go in. So I can go into CMPS 12B. And then if I hit ls again, which lists everything in the directory, now I have lab 1, I have lab 2, lab 3, and so on. So for this kind of demo, I'm mostly going to be going over lab 3. I genuinely don't remember how it works, but I can kind of explain how ADTs work in that sense, and how you might go about doing that. So all right. So if I want to go into lab 3, I would just go cd lab 3, and if I want to go back, like a folder system, I would just type cd and then a dash, and if I go ls again, now I'm back. So cd lab 3 ls, and it lists all these files. I don't think I might go over the make files. We'll see how it happens though. Okay, so for the basics of C, if you've ever taken Java, this this will be great for you. Um, so um, for the starter of C, it looks pretty much like Java, but it's kind of different. I don't know how to use Python. I've heard Python more like it's like a scripting language. I know Lua, so that I've heard those are kind of distant cousins. Don't get mad at me. I'm not technically a CS major. This is for my minor. So, um, but basically, you'll have a function called main right here that just has something. It just does something. The 2 arguments it always gives is int argc. These can be named anything. It doesn't matter. You always put int or long or char in front of a variable when you're declaring it, because it tells C like, hey, this is what type it is. And then the other one is a char star star, and it's called argv. So unfortunately, and this is the thing I don't like about C, but it's not that bad to work with. C doesn't do strings. Instead, strings are just character arrays. So that's a biggie that you want to learn right away, is that it doesn't do strings. So you can't, in Java you could just type string and then, you know, just a, let's see, example variable, and you could just set that to, you know, hello world, and that would work, C does it differently. Instead, you have to declare it either by size or you have to malloc calloc it, and I'll get to malloc calloc later on. But C doesn't do strings. So going back to this, you have a function called main. It opens up everything in between the braces, just kind of, it just does something. You have int main. So the int part before main, that just tells the compiler, or not the compiler, but, or maybe, I don't know, whatever's reading this code, that it's going to return a value of type int. And so you can see down here, it just says return exit success. Exit success is just kind of like, it's like a macro. It just says like, I think it's equal to 1, maybe 0. I forget which one's like true or false. That's another thing that C doesn't do, is booleans. So if you're used to using booleans, which is true and false, they don't exist. Use 0 and 1. I don't remember which one goes to true or false. It's been a while since I've done C. But there's exit success and there's exit failure, underscore. Declaring new variables in C is the same as Java. You just do the type, what it's called, and then what it's equal to. And every line you have to put a semicolon at the end, but not including for loops and, if function or if statements or that kind of stuff. You don't have to do that. The pound include up here, that just means that you're including a library. So in this case, we're including the standard lib library, or std lib. So it's just including, the lib. We're also including the standard IO, input output. So that would be like your standard like input, print, I think puts. So, etc. So if we didn't have this, I don't think you could use printf. I always have it. So it's you could put it up there. You don't have to, depending on what you're doing for your C program, but I mean, traditionally, you kind of want to know what your program's doing by printing something. And the next thing is pound include integer stack.h. That's this file right here. In PA1, it should be called list.h. And the reason why we use quotes is because it's not one of the bigger libraries. It's not, I don't know the real reason behind that, but my guess is that it's something we made. It's not included in the libraries and the H files that Windows or Mac OS or whatever C compiler you have provides. So we have to, that's why we do the quotes, not the alligator brackets, whatever they're called. I forget what they're called. Okay, so int argc, what that does for main, this is only for main. Other functions you can have different types. Argc just tells you how many variables there are when you call on this function from, say, your command line like putty, or you could call it from git bash. You could do that. The first one is always the name of the program, and then anything after that is whatever you call it. So over here, I could say integer. I could say call it integer stack, and then the first argument could be like just arg1, arg2, arg3. So in this case, the argc over here would be equal to 4 if I hit enter on this. And then argv, that's the next thing I want to talk to you about. That's an array of character arrays. So just how I mentioned how C doesn't do strings, instead strings are character arrays. So if you wanted to declare an array, so originally you could say like string, and we'll just call this Java. Oh, by the way, comments, you do a double slash. You could say string my string equals just my string. In C, it's different. We do char, the name, my string, and then let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then we want to do 11. And I'll tell you why we do 11, not 10. And then that will look like something like this. M, comma, Y, comma, space, comma, S, comma, T, comma, R, comma, I, comma, N, comma, G, G, comma, that. And then whenever you're ending this string, you always put a backward slash and a 0. And that just tells the computer you're done. Stop reading from this array. Basically, originally in Java, it wouldn't look like this. You could just put it like that, but C says no. C says you can't do that. But let's say you don't know how long your string is going to be. There's ways to do that. Yeah. So another library that you should always probably include is it's called string.h, and that has a bunch of really useful tools for string manipulations. And in PA1 you should use one. There's one called string.token, or not string.token, str.talk. It just grabs a token. There's also strlen. So I'll put out, let me just write this out. So we have strlen, and that will get the size of the array. So if I called strlen on my string for C, that would return I think 11, or it might be 10. I'm not sure if it includes the end signal, but again, I haven't done C in a while, so experiment. And then there's str.talk token. That just gets a token from, there's a certain way to do it. I don't know how to do it. Pat included it in his example, but when I did PA1, I didn't use it. There's also strcmp, which takes in 2 strings. And again, remember, strings are a collection of characters, so they're just character arrays. There's no thing as a string in C. It's just an array of characters. And then that will return a number. It'll either return -1, I think, if one of them is alphabetically superior, 0 if they're the same, and 1 if the other one is alphabetically superior. So that's all the ones I know off the top of my head for str. I don't really use a lot of the other ones. So yeah. So going back down to here, for loops are the same. I'll get to this stuff up here later, but I just want to get through your basic for loops. So for loops are kind of the same way in Java. Actually, they are the same way in Java. You still have to declare a variable. So I might say for, I can either declare the variable here and make it equal to 0 or whatever number I need it to be, or in this case down here, I can just have it be equal to, I can have it declared before I do the loop. It doesn't matter. The next thing you want to do is do the conditional. So if this is true, iterate again. If it's not true, get out of the for loop. So I'll just do if it's less than 15 or less than or equal to 15. And then if that is true, what do I do next? So down here, I++ just means we add 1 to I. You can do I minus minus. You can do plus plus I minus minus I. The difference is that the plus plus before and after, that will be that increments or decrements um, either before or after the compiler runs through the line. So in this case, we'll just do I++ because we want it to iterate after we go through. So that means all this jargon code, I will still equal 0, and then when it ends and finishes all this stuff, I will be 1, and that'll go all the way up until it equals 15, or actually until it equals past 15. Okay. So what's something else I can explain? Oh yeah, since I++, you don't have to do for loops like that. In PA1, you could have it be like move next, and then whatever it is. You could do right here. You could say index of L. I saw this on Piazza, and I was like, oh, that's cool. I didn't do it like that, but you can do it kind of like this. So for int I equals 0, or they had it a certain way, but anyway, it would check whether the index of L is not 0. If it's not, oh, that's another thing. Not is exclamation point equals sign. In Lua, if you guys are familiar with that, it's like the squiggly line. It's like that. But in C, it's that. So make sure you don't confuse the two. So in this case, this one, if index is not 0, then move next, and then do all this jargon down here. So that's what I'm going to do for a loop. Functions are the same way in Java. You just declare, char example function. Just kind of looks like that. You can have a bunch of arguments. So I could say int arg1. I could say char arg2. I can say long arg3. I can say double arg4. And so on. You can name these whatever you want. They could be anything from like poop to pee to dollar to num to duck to hand to toilet paper to it could be anything. So in my experience, when I try to explain code to people, that doesn't click. That you can name them whenever you want. So I mean, everybody's in 101, so you should know this, I guess. If statements are the same as Java, if something, then do blank. So if say like arg1 equals 4, do this. Else if I hope you guys know what else means. If you don't, you should look that up. Basically, else is just like if this one's not true, then it'll check this. It's almost, in fact, it's actually the same as this. But it's like having an else and then an if inside that else, and so forth. And then you have else. We'll say arg2 equals b, and then do this, and then if neither of these are true, then do this. So if this condition isn't true and this condition isn't true, then just do this. And then I've seen this happen a lot. Whenever you're doing a C program, make sure you always have it, and it's going to return something. Make sure you always have it return that thing. So I could just return b. Oop, there we go, b. And so then this function is valid. It works. What else do I want to explain? Yeah, for loops are the same. Let's go over print. So when you're printing something, there's two types. There's printf, and then there's fprintf. And the F just stands for format. I think in fprintf it's file print format, or I don't know what the first F stands for, but I'll explain. So you could have so print f just goes to your standard out, or any other file stream. And the first argument is always a string, so we can say hello, my name, or let's say my character equals, and then Java, what you would do is you would have a plus and then the argument. I don't think you can do that in C. I think I tried experimenting it. You can try it, but what you should be doing is percent, or not percent, or no, wait, is it percent D? Yeah, okay. It should be percent D. And what that just means is that the first or the second argument in the printf. So we'll say, oh, actually that should be a number. We should call that a number because that's going to be a number. It's a digit. The D stands for digit. And then what this is saying is at percent %d insert arg1. So whatever arg1 is, and it's an int, insert into percent %d. I can say my char equals percent %c. Percent %c would be your character. So we can say arg2 because arg2 is a character. And actually, I'm going to put char star arg5. Don't worry about what the star means right now. That's more like pointer stuff, but we'll get to that in a second. You say my string equals percent %s. So I mentioned how strings don't exist in C, but they do. When you put a percent %s in printf, that's just telling the function that, like, hey, I'm leading you to the first entry of a character array. So I mean, that means arg5 would point to this m, and then the printf function would be like, oh, okay, this is the first letter. Okay, print out the first letter. Okay, go to the next one. Go to the next one, and it's gonna go all the way down to m y blank string until it hits this /0, and then it's like, okay, we're done. The string's done. We're done. We're good. Okay. There's also percent %f, which is for floats. I don't remember the exact formatting. It's like you could do like 0.1f or something, or 0.1f. It's something about how many digit places you want to do. I would check that out online. I don't remember exactly how that works, but that's I think when I took 12B, we only used it in like one lab, and I think it was on the test like once. So good thing to know though. So make sure you freshen up on that. Yeah. Okay. And then also you can do percent. I think you can do percent %i. Actually, the percent %d might not be digit. It might be double. You can scale up anyway. Oh, and that's another thing. You can still, if you took Java and you learn typecasting, where you could say like double, say j is equal to int arg1. That's still valid. You can still typecast. You can actually not int. You can say double. You can say char c equals char and then arg1. So you take the int, and then in this one you would turn into a double, and this one you would turn into a character. That's still all valid. You can still do that. Function calls are the same way. So there's a function called new integer stack. You just call it by using some nice parentheses, and then whatever arguments you supply to that, you would just throw in those braces. So in this new integer stack, if I wanted to supply I could just type I. If I wanted the next one to be n, I could type n, and so on. You don't have to do char I and then int n. You can just throw those in, because when you declare the function, the compiler already knows what type they're supposed to be because you've already told them. So up here it's an int, it's a char, it's a long, it's a, etc. And you'd also have float. Float's another one. Like I said, booleans, none of that doesn't exist in C. Don't try to. It won't happen. Just do integers, and just do ints of like 0 and 1. That's your best bet. Okay. So, another thing is if you want to do a new line, you just do /n. If you want to indent, it's /t, I think. And then there's another one called it's /r. I don't remember what that one does, but you can look it up. But you'll only use /n and /t probably. You might even not use /t. Oh, and also I forgot about fprintf. So basically, fprintf, it's literally the same thing as printf, but you're outputting it to a certain output. So printf would just do std out. So that's just standard output. So that would be, if you called it from your git bash, or your git, then the standard out is that window. If you called it from putty, it's that window. If you called it from console, it's from that window. If you called it from the terminal in Windows, that's what standard out is. Standard in is also the same thing because it's what your input is. So, but you won't be extracting input from this class. I don't think so, but I don't know. You might. Oh, so then after standard out, then you would just type what you want. So I could these two things are equivalent. They do the same thing. Make sure though, if you have like percents, if you have a bunch of percents, make sure you always have an argument for that. Otherwise, they'll throw an error and be like, "Hey, you told me to put a string here, but there's no string," or "You told me to put a float here, but there's no float." So, and then make sure you don't oversupply. You'd be like, or otherwise they'll be like, "Hey, I did this all for you, but there's still more information that you gave me. So what do I do with this?" So make sure you just do that right. Yeah. So that brings me to my next thing, which is .h files. So what the hell are .h files? .h files are they're called header files. So basically, when the computer runs and compiles it all, it always checks the H file first. That way, when it starts sifting through the other stuff, all these functions are already declared. So you have a function called integer stack that returns an integer stack. We have a function called free integer stack, which has an argument that points to a integer stack. Also, void just means it returns nothing. So it just returns nothing. I'm gonna get some water real fast. Okay. So we're going on 28 minutes now. So yeah, and so basically, yeah, void that means returning nothing. So if you go back to integer stack, if I put void here, then I don't need this line here because you're telling the compiler I'm not returning anything. Don't expect me to return anything. So basically it's going to declare all these functions beforehand. It's not going to tell you what they do. It's just saying that a header file says, hey, look, these exist. We don't know what they do yet. That's what integerstack.c does. So in PA1, list.h just says, hey, look, there's all these functions that exist. So when it goes to compile other .c files, it doesn't go, hey, look, why are you trying to use this function? It doesn't exist. But they do because it did the header files first. So, yeah. So basically, that's what they do. So there's a function called isEmpty. It returns an int. Push returns nothing. Int void. All of these include an integer stack 8 or integer stack s as input. This one has void print integer stack. The file star out. That file star is just an actual physical file. Depending on where where the program is, those files will typically be in the same directory. Otherwise, you have to kind of like you shouldn't worry about that. You would just put the actual like string name of it, or not the string name, but I'll get to files eventually. Um, so right after all these functions are declared, oh, and we'll get to type defs in a second. But if and def stuff, Pat went over this a little bit, I think. I don't know if we got too far. I kind of zoned out around that area because I already know all this stuff. But basically, what it just says, just that this piece of code doesn't run over and over again when you're calling in a program. It'll just say, if n not defined, if not defined, this macro, then define it. You can kind of think of it as like this. So if it's not defined, define it. Create all these function headers, but we don't know what they do yet. But they exist. And then just end it. Just end the macro. So every time you call in the program, you don't need to do all this stuff, and you don't have to worry about it overlapping with integer stack.c. So then when you actually, and again, you don't need, I don't know why I included this here, but you don't need that technically. You don't need to include files. I always just kind of include these everywhere just because you never know what'll happen. You never know. So then going over to integer stack.c, now this gets into the guts. So when I do Pat's assignments, he usually gives you the .h file. What I do is I just copy all of this, not that actually. I just copy all of the function declarations, put into a C file, and then just start filling them in. So we have, int is empty, and then I'll go and actually make that. Where is it? Oh, here it is. And then I'll actually fill it out. Side thing. In some languages, it's called nil. In C, it's called null. All uppercase. All uppercase. Or uppercase. Sorry. Right. So that brings me to pointers. So I'm going to get to pointers real fast. If you don't know about pointers, you should definitely go over pointers. Basically what pointers are, and I'll also go over malloc and calloc. So I think I'm gonna get all this out. Ooh, come on. There we go. So we're just gonna get rid of that. Let's start with our own new main. So for pointers, basically if you have an int c equals say 5, and then you have int star c pointer that equals to the address at c. Basically, imagine it. It's kind of hard to explain in words. I'm sure Pat will do it Tuesday on how pointers work. I never took the CSE 13 series, so I don't know what they did there. But basically what the pointers does, think of int and int star. Don't think they're the same thing. They're completely different things. There's also char and char star. There's double and double star. Think of them as completely separate data types. They are not the same thing. They work similarly, but they are different things. Int creates a variable that is equal to 5, and int star c pointer creates a variable that points to the memory address of C. Um, and you put the int star next to it because, or you put the int next to int star because that's the data type that it is. It's originally an int, but you're pointing to an address called C pointer. And then this and symbol that just tells the compiler like, hey, this C pointer is equal to it's equal to the address of C. So then C pointer becomes 5. Well, that's kind of confusing, wasn't it? Pointing to the address. Well, yes. What I can do is I can say C pointer equals, or int star, or star C pointer equals 10. And then if I print C, C will equal 10 because I changed the address. I changed the value at the address of C through C pointer. C pointer, that variable just points to the address of C. And what's at the address of C? 5. So if I change the value of the address at C pointer, then C becomes whatever I assign it C pointer. So now if I went and I printf'd and I said, new, we can say C is now equal to we'll say %d, and we'll say C pointer is now equal to %d, and I put C and star C pointer, then you should get 1010. I hope that makes sense. It's kind of easier drawing it out. If I'm confusing the star and the star is not supposed to be there, or the star is supposed to be there, I'm so sorry. I haven't done this stuff in a while. It's usually easier when I usually type def everything, so yeah. Anyway, hope that explains for pointers. A cool kind of application of pointers is like, well, let's say you have a function and you want to return 2 numbers, but you can't because functions only return 1. So let's create a function called add subtract. Yeah, that's how you spell it. And we'll have just int arg1, and then int arg2, and then int star, let's call it ret2, and we'll declare it. So then we're going to say we return arg1 plus arg2, but what if we want to know the subtraction of that 2? Well, that's perfect, because we can say ret2, ret2 is equal to arg1 minus arg2. And so what we're doing is we're supplying a variable called ret2, and what we're doing is we're changing that value at where ret2 actually is. This isn't a new variable. This is just pointing to where the variable we just supplied is and subtracting it. So we could say int ret equals 0. We could say int result equals add subtract, and we'll say just 5 and 1, and then we want to supply the address of ret, so we'll do the and symbol and put ret, and that'll work. So now result, when going through this, result is just this right here. So 5 plus 1 equals 6. So result will be 6. And then ret2, which is the address at ret, which is right now 0, is equal to arg1, which is 5, minus arg2, which is 1. So now ret down here is 4. So kind of a cool application of pointers. Super duper useful. I'm sure he'll get it into it later on more in 101, but that's something you should for sure know. Okay, and then I think that brings me to my last topic, which is ADTs, and kind of how to set them up. So he mentioned he talked about this in his last lecture on Thursday. So he talked about type def and what type def does. So what type def does is it basically just rename, or it creates an alias for a certain data type. So this right here is just one data type. Don't think that's two different arguments. That's one thing. That's one thing. And then we have something right here called integer stack. So what I could do, we'll come back here. I could say type def, and we'll say int, and we'll say integer. Bang, that works. Basically what I've said now is that the data type int is the same thing as integer, and when I call integer, the compiler should think int. So now I can just type integer c equals 5, and that works because you're telling the compiler that, hey, whenever you see the word integer, what I really mean is int. And so this works. And so if I type int c equals 5, these things are completely the same. They're the same thing. So this is really, really useful when going back to here, you have struct integer stack obj star. So instead of having to type struct integer stack obj star every single time, let's just type def it. It's just one thing. Let's just rename that to integer stack. That's all we have to do. And so basically what this is saying whenever the compiler encounters integer stack obj star, and again the star means, remember, it's a pointer, anytime the compiler sees that, it's the same thing as integer stack. And whenever the compiler sees integer stack, think the same thing. It's still, just think, oh, it's struct integer stack obj. That's what it is. And I'll get to struct in a second. Basically, struct is like, if you took Java again, it's like you create a new class. It's a structure of items. So if you took, well, I didn't take the coding classes here except 12b, and just thinking about it that way. So if you create, like in Java, if I created a person class, I could say like person new equals, oh wait, person p equals new person, or something like that. This is basically we're creating and this person, that would be its own separate file. That's what we're gonna do with struct. Yeah. So basically that's what struct does. Or that's what type def does. And the reason why we have a star here is the star just says like this exists somewhere. It's a point. It's just saying like anytime, how do I explain this? Integer stack is the same thing as integer stack obj struct, that whole thing, but the compiler, if you're confused and like, well, we haven't declared integer stack obj, how do we know what it is? How would the compiler know? And that's why the star is there. It's saying that eventually, when integer stack obj is created, this just points to that. We don't know what it is yet, but it points to some area in memory where it will then be allocated to that. And we'll actually create the struct in integer stack.c. So I hope that helps a little bit. If not, you can just message me, or there's other people that can help you out with that. So we know there's going to be an integer stack obj star. That struct, it's going to be somewhere, and when it's declared, we can just call it integer stack, and that's type def, so they're the same thing. Which then brings me to integer stack c, and that's where we come up with this thing right here. So here we go. So what we're doing right here is we're now creating the structure. So what we do is we do type def, And you don't really have to, you don't have to do type def, but it's kind of useful. Um, Basically think about it like separate into three parts. That's one, that's two, and that's three. This is the same thing as saying, um, we don't even need this stuff right here. It could be like that. Um, Come on. That's the same thing. So one, this is one argument kind of thing, and third one. So basically, what we're doing is we're creating a structure called integer stack obj. We're now creating it. Back here, we just said point to it when it exists. Now we're actually creating it. Um, and inside it will be an int star. It'll be a pointer to an integer called items, or the pointer is called items. An integer called num items, and an integer called physical size. And then when we create that structure, create an alias, rename it to just integer stack obj. So instead of having to call struct integer stack obj every single time, we can just do integer stack obj. I don't remember the reasoning behind integer stack obj, and then like why not call it just integer stack obj, not integer stack? Or Pat will probably he'll explain that much further when he goes into ADTs, but this is just kind of like a short explanation. Oh, when you do your .c file, make sure you pound include in your stack.h, so that will that'll again pre-create all these functions. We don't know what they are yet, but they exist. It'll also allow you to use this type def, this integer stack. So when you start declaring stuff in here, you can call integer stack, you can create a new one, you can do all that kind of stuff. And that's what all these functions are for. And again, all these functions just fill in the blanks for the H file. That's all it does. So then going back up to here, you don't need to worry about what this is. If Pat wants you to know what it is, he'll tell you. So the last thing I think that I'll explain is probably malloc and calloc. And then there's another one called realloc. I didn't get a chance to learn that in his 12B class, but I think it just reallocates. I don't know what the M stands for, and I don't know what the C stands for, but it exists. Which brings me to my next thing, which is heap and stack memory. So there's tons of types of memory, like for like programs. But the ones that he taught us was just stack and heap. So what stack is memory that the computer allocates for you while you're creating variables and storing data. Heap memory is memory that you allocate yourself, and that's where malloc and calloc come into place. That's memory that you get to deal with and you get to manage. So let's say I wanted to create my own place in memory that how do I want to explain this? I'm going a little brain dead right now. Been talking for 49 minutes. So malloc. Okay, go and skip this part. I'm hitting a brain fire right now. Let's just say. Okay, so malloc and calloc or allocating your own memory on heap it's really really useful when you want to do your own memory management, and you also want to pass a specific variable over. Because let's say like right here, if I pass over on add subtract right here, if I pass over C, that just passes over the value at C. It doesn't actually send the variable C itself. So what I might want to do is actually create my own or my own malloc um, variable. So I can just say like int. You want to do int? Do I do int star? No, no, I don't. You can say like int h equals malloc, and then um, the what there's only one argument to malloc, and that's just how many bits you want to allocate for yourself to use at int h. And so I don't remember how you don't have to know how big each data type is. I think int is 8 bits long. I think double is like 64, I think, or 32. Char is 8. You don't need to know that. You could type 8, or you could type 4, you could type 1, you could type 2. It doesn't matter. But what you can do is you can type size of, and then type in the data type that you want. So what that'll do is it'll just look up the size of int, or it could be double, or it could be whatever. That will return 8. Malloc will go, okay, we just need 8 bits allocated for you, and now h is equal to that. And so now I can say h equals 5, and then that just works the same way. But this is where memory leaks come into play, because at the end of a function, if the compiler will free all the stack memory, because that's memory it created itself, but you yourself need to memory manage the memory you did with malloc. So what you'll do is you'll just type free and then the variable h. A common issue in programming assignments for Pat that I've noticed is that people will double free. So if you've already freed something that's malloc or calloc, don't do it again, because then you'll get an error, and then you'll hate yourself because you can't find out what's wrong, only to find out you've been trying to free it twice on that one line in that very obscure place, and then you're like, ah, God, whatever. So then what the hell is calloc? So what calloc is, and calloc is good for creating arrays. If you didn't want to do it the old-fashioned way, like you did in Java, calloc basically is malloc times a certain number. So we can say int h2 is equal to calloc. The first argument is how many you want of, say, a size. So if I want 10 integers, I would just type 10. And then the second argument is how many bits you want. So I'll just do size of int. Oh, and actually this should be int star. Actually, yeah, they should both be int star, I'm pretty sure, because it's pointing to a specific location in memory. So that should be h star. Oops. Okay. Again, I don't know what I'm doing, so don't. This is a really, really rough explanation. I'm not really. I think I did bad on that test about pointers, but I know how they work. But you should look up more tutorials about that. This is kind of a quick. This is the how to for dummies explanation right now. So what h2 will do now? What h2 now is an array of 10 of integers by size of int. And so what I can do is now I can use h2 for whatever the hell I want. I could say h2. Oh, why is there 2 right there? h2, and then the 5th spot is equal to 6. I can do h2, the 0 spot, or the first spot, is equal to 10, etc. all the way down the line. And that's calc and malloc. You could use malloc or you can use calc. Um, if you want, you could just do 10 times up here, size of int. These two would just be the same thing. There's no real difference. At least what I learned. If there's some really cool programmers watching this and they know a lot more about malloc and calc, then great for you. I don't. um, that's kind of the explanation of it. So going back to integer stack C, when you want to create a new integer stack, or in PA1's example, a new list, what you'll do is you'll malloc the size of the integer stack obj. So then what that'll do is it'll grab the size of this, which will be 8 plus 8 plus 8, which is 24, or I think it's 24. I don't know. It'll return that, so then it'll malloc it, and then now integer stack S is equal to the obj of that, or the pointer to that new struct. Which then brings me to my next thing, and I think probably one of my last things, is that you've probably seen this arrow thing, and you're probably thinking, what the hell is that? The reason you use that is you either can do that, or you can say Pat had a reason for this. Can I remember it? It was like star S, and then I don't remember this part, but just know that you'll want to do this arrow if you're accessing something in here. It's something to do with pointers, but I can't remember it. But that's just something. Just make sure when you're accessing a variable in a data type that you've created through malloc or calc, or a struct that you've made through malloc or calc, to just always use these arrows. It's something about pointers. It's like doing 2 pointers. I don't remember how it looks. I'm so sorry, but hopefully this is helpful. Hopefully this helps a little bit with how PA1 should work. Again, I'm not going to explain how to upload to Git. There's a lot of resources for that. Make sure you do all your test code on the timeshare. I've seen people have said it's really buggy on there. Personally, I've never experienced that. But that's where your code's going to be ran when it's tested and graded. So your best chance is to do it on there for the best grade. I hope I'm not forgetting anything, but yeah, make sure you use timeshare. Refresh yourself on what pointers are, malloc and calc, and then type def. And then after all that stuff, and structs for sure. After all that stuff, I think you're pretty much good. If we're coming up almost on an hour, so yeah. All right. I wish you guys the best of luck in CSE 101. PA1's not that hard. Don't overthink it. My strategy is don't even worry about lex.c. Don't even do that yet. Don't even do that. Your first thing that you want to set up is integer stack.h, or you want to set up your h file first, because again that'll preset all the functions that you're going to be filling out. Then your next thing you want to do is you want to go to integer stack, or God, I'm looking at it and I'm reading it, but don't. The next thing you want to do is you want to do list.c, and actually copy and paste everything from list.h. Don't include the pound include. Don't do the if and def. Delete that. Make sure you have all your necessary includes. So just string.h. And then just fill in all the blanks. If you need to do pseudocode, do pseudocode. And then once you've done all of that, then move on to lex.c. and then figure everything out from there. I hope this helps. If you have any questions, let me know in the Discord, jason.exe number 4484, and I'll see you in the next one. Peace. Actually, I won't see you in the next one. Well, maybe I will. I don't know. We'll see what happens.